In this video, we're going to look at posting or marking a true line from a random line. In this case, random east-west line. I'm going to use the example I used earlier, and I'm going to turn on or tag a traverse up here called random line. And let's go ahead and open that up. And what we see in this traverse is that we started at point 201, an existing corner, and we ran this random generally west line over to 202, which was another corner position. And let's take a look at that in the drawing and see what we actually have here. I'm going to zoom in around this area from 201 to 202. I've got the zoom points turned off here. That's just a little option in Traverse PC that as we zoom in the drawing, the points get pretty large and the labels get large, so we can turn off that zoom, and just allows me to see a little more clearly what I'm actually working with here. So this is the random line from 201 on the east side over here to 202 on the west end of the line over here. And I've just basically created these positions. They could be offline by quite a bit. But I just wanted to have something to show you how this works. Let's come back to our traverse. Let's go to COGO, and we're going to choose the offset interval option down here. And let's take a look at this dialog here. Our line is going to start at 201, so we type in 201 for the start. It's going to end at 202. And Traverse PC displays the bearing between those for us. Now, I'm going to come down, skip the option here just for a moment. I'm going to tell Traverse PC that I want to create true north-south or cardinal offsets from these random points to the line. And I want to account for the latitudinal arc between 201 and 202. So I'm not offsetting to a line of sight. I actually want the true line between those. And as we saw in one of the earlier videos, I have the option in many of the COGO dialogues to choose what kind of bearing I want to work with. So in this case, I want to work once again with the true bearing. So this is going to be true north or true south from every one of these offset points. Now the options in the middle really just decide how I want to create those points. I want the first option that says I want to save them as side shots in my original traverse. So from each random point in my random traverse, I'm going to have an offset or like a side shot to the true line. So I can go back and print out those notes and actually set off that line in the field. Now I've got some options down here as to how I want to label these new points that get created, but I'm just going to hit the compute button, and we're going to take a look at what Traverse PC does here. Let's click on our drawing and drag this out of the way. Can you see that Traverse PC has gone in to every one of these random turning points on our random line and created an offset to the true line. And I see that for every one of these points all the way down, I've got an offset. Let's bring our traverse view up, and remember the option we selected was to add an offset point to each of the random turning points. So let's highlight example, for example, point 300. Here's the offset from 300 called 300 OFS. It's an offset point type, and you see that here's our bearing for the offset due north, and here's our distance, geodetic distance, to the true line. Remember, I just clicked in some points, so our offsets are pretty large here. But this is ground distance, okay, at the project elevation from the offset point 300 to 300 OFS. And if I come in over here on the drawing, that particular point would be right here. From 300 to this offset point right here is the one we were just looking at in the traverse view. Now, there's also a report that we generate for this, and I'm going to click the summary button, and Traverse PC, we don't need this open anymore, comes up and displays for us the offset interval using geodetic distance and true bearing for north-south offsets to a line from 2001, should be to 2002 here. Here's our bearing, and here's the latitudinal arc. So it's taken the mean latitude, the latitude of the beginning of the line, the latitude of the ending of the line, and mean them for us. And that's the latitude it's using to compute this arc, or amount of arc that we're dealing with. And then it tells us that each of the distances reported here is a geodetic distance at project elevation. and that my offset directions are true bearings using the mean course convergence. So for every point on the random line, starting here with point 300, I get a bearing to the true line. I get an offset distance, in this case in feet. I have a distance from the start of the line. Okay, so how far from that existing corner that I started from, 201, am I along the true line? Okay, this is along the true line, not the random line. And then it just tells me the convergence that it used to equate true bearing and grid bearing for that particular offset. Now when I drop down to the next random point, 301, I get the same information, but I also get an interval. So this is what distance on the true line from the previous offset point from 300 to this offset point from 301 is involved in that offset. So I get the interval for every one of these offsets, and finally when it's all said and done, I get an average offset distance and an average interval